Got another test for you, the root test. Sounds like something that would happen at the dentist's office, right? I have to go in and have a root test today. You're often going to use it when an involves a function of n to the nth power, or it could be a multiple of the nth power, or a multiple of n, of a power of n, just to be specific. You'll see in the example in a second. And you could prove this test in a similar fashion to how you prove the ratio test. And it looks very similar as well, except instead of looking at the ratio absolute value of an plus 1 over an, we look at the nth root of the absolute value of an. So number 1 says if the limit as n goes to infinity of the nth root of the absolute value of an equals L, which is less than 1. So same condition as the ratio test, it's just the thing we're taking the limit of is the only thing that changes. If that's true, if that limit is less than 1, then the series converges. And what am I saying here? What kind of convergence is it? When I say the sum of the absolute value of the an converge? So we really are talking absolute convergence. It converges absolutely. And then if that limit, number 2, if that limit, nth root, absolute value of n goes to infinity, is greater than 1, then the original series diverges. We don't say it diverges absolutely, it just diverges. And then if that limit equals 1 as n goes to infinity, then we're out of luck. The test is not conclusive. So very, very similar test. You use the ratio test a lot more often, but here, let me show you when the root test comes in handy. So example, does it converge? So we have the sum n equals 1 to infinity, 2n over n plus 1 to the nth power. And so the thing that gives it away here, which test to use, is the fact that you're bringing a function of n, 2n over n plus 1 is a function or a formula of n. The fact that you're bringing that to the nth power, that is a cue to use the root test, not the ratio test, to prove that it converges or not. Oh, okay. So then let's, in a similar format to how we did the last 3 examples, let's start out with the generic sequence that we want to look at. So we want to look at, in this case, the nth root of the absolute value of an. Now, what is an in this case? This whole thing, right? Well, in the box, that whole thing in the box. Get rid of the sigma notation for an. So that whole thing is an, 2n over n plus 1, all to the nth power. That's an. Is it going to matter if we take the absolute value here? No, notice an is strictly greater than 0. So the absolute value of an is the same as an, so you don't need to use absolute values here. I will make a kind of a note of it by saying this. The nth root of absolute value of 2n over n plus 1, that whole thing to the n power is just the same. You can drop the absolute values. It's just the same as the nth root of 2n over n plus 1 to the nth. And if you had just gone to this step right away, I would probably not worry about it. But if your an can go negative, you need those absolute values there. And you need to hopefully be able to get rid of them. Usually it's just a factor of -1. It's an alternating series. So it's just a factor of -1 that's a problem. And if you take the absolute value, that factor of -1 to a power, would go away. Okay, so we get that. And then what's nice here? What's the nth root of 2n divided by n plus 1 to the nth power? Since you know 2n over n plus 1 is positive, what is that? Yeah, it's just 2n over n plus 1. Nice. Okay, we know what that thing does. It's a rational function. 2n over n plus 1 is a rational function, meaning there's no square roots around the n, right? You don't have any formula of n in the numerator or denominator any formula involving n brought to like a half power. It's a ratio of two polynomials, in other words. It's a rational function. We know what they do. We base our answer on really it's the non-calculus way of figuring out this limit. The degree of the numerator versus the degree of the denominator, what are they? They're the same. So when that happens, it converges to what? 2 over 1, right? The ratio of the lead coefficients, which is just 2. No explanation needed, except just realize what the arrow means. Every once in a while I remind you, because notation is everything in math. It means the limit as n goes to infinity of 2n over n plus 1. Okay, and then you could say that equals 2. So that would be an alternate way of writing, let's see, this part. So in an alternate way, in an alternate universe, you could write it that way, alternate universe. So how does, same as ratio test at this point, how does 2 compare with 1? It's greater than, so what's your conclusion? The series diverges by the root test. The series diverges by the root test. I mean, if you think about it, these tests aren't as bad as the integral test, right? They're not that bad at all.